Let's discuss about wireless network technologies. Over the past 5 years, the world has become increasingly mobile. So, wireless technologies enable one or more devices to communicate without physical connections. Wireless technologies use radio frequencies transmissions as a means for transmitting data, whereas wired technologies use cables. So, we can identify benefits of wireless networks as user can move about and get access to the wireless network while working at an outdoor location. And, and also user can send information over the world using satellites and other signals through wireless networks. So wireless network technology plays huge role in nowadays. In next, let's discuss about basics of communication fundamentals with standard bodies. Let's move. Standard bodies and layered architecture. In this slide, onward, let's discuss about basic fundamentals of wireless network technologies as I mentioned in above slides. We all have heard of standards and use them in our daily lives. But do we really know how they are developed and adopted? Most people do not. In here, let's discuss about what are the standard bodies. We can say it as standard bodies are any other organization that creates, establishes and coordinates standards for people and organization to increase the quality of products or services likewise. In other words, organization in a private or public sector, also national or international, that process, monitors, develop voluntary standards. For example, ANSI mean American National Standard Institute and ISO mean International Standards Organization and IEEE Institute of Electrical and Electronics Engineers Standards Association. All organizations develop standards. Let's see what are they develop or what are they create. As mentioned in previous slide, standards are developed by standard bodies. Institute of Electrical and Electronic Engineers produce standards for broad range of industries such as electronics, telecommunications, information technologies, and also home automation. And networking standard bodies define rules of communication among the network devices. In above, we got a clear view of what standard bodies are and what standards are. Then let's move to IEEE standards. IEEE standards are IEEE 80.3 and IEEE 803.11, IEEE 802.3 for Ethernet Local Area Network (LAN). This standard communication medium is coaxial cable. This standard use MAC and CSMA CD, and good thing is efficiency is high in this standard. And also this standard has a large range. Then 803.114 wireless local area network WLAN. This standard communication medium is infrared or radio frequencies because it's wireless. This standard use 2 MAC sublayers and CSMA CD. Efficiency is low in this standard and this standard has a short range. And there are many other standards in IEEE such as IEEE 802.8 for fiber optic connection and IEEE 802.7 for broadband LAN cabling. Let's move to next slide. We can get clear idea about layered architecture from this introduction. Let's think there are n number of users who use computer network and they are located over the world. So to ensure national and worldwide data communication, system must be developed. So which are compatibly to communicate with each other. ISO has developed a standard. ISO standard for International Organization of Standardization. This is called a Model for Open System Interconnection, OSI, and is commonly known as OSI model. It's model for understanding and designing a network architecture. So OSI purpose is to communicate between different systems without requiring changes to the logic of the underlying hardware and software. And there are some advantages in this model, such as OSI model is very useful for troubleshooting network problems. And simple meaning of the OSI model is it allowed two different machines to connect without changing hardware and software. In here, let's discuss about what is the process of ISO OSI model. If one machine send data to another machine, it called sender and receiver. So process start at the layer 7 in application layer, then moves from layers to layers in descending sequential order. Finally, data until comes to physical layer, it is changed into an electromagnetic signal and transported along a physical link using transmission media. Upon reaching its destination, the signal passes into layer 1 and is transformed back into digital form. That is the process, simple process of ISO OSI model. Let's discuss in detail about 7 layers. Application layer. This is the first layer of OSI model. Application layer is the one which only close to the end user. When user requests content from application layer, this layer provides application service for email and also file transfers. So then application layer returns content in required format, such as web browsers and other internet connections. Google Chrome, Firefox, Safari, Skype, and also Outlook. The next layer is presentation layer. Presentation layer is responsible for translation, encryption and compression of data. In this layer, translating incoming data to understandable syntax that the application layer can accept. So it is sometimes called syntax layer. We can get examples as ASCII, TIFF, GIF and JPEG. Our next layer is a session layer. When two devices such as a computer or server need to communicate with each other. For this, a session needs to be created. So it's called session layer. The session layer setup, coordinate and also terminates conversions between applications. Session layer protocols such as X225 and AppleTalk and also Zone Information Protocol can get as examples. Let's move to next layer, transport layer. Transport layer receive data from the session layer. Session layer is previous layer and breaking it to segments and then it sends to next layer. It's called network layer. It's also responsible for end-to-end error recovery and flow control. So transport layer examples are SPX and TCP and UDP we can get. So let's move to next slide. Next layer is network layer. If data transfer between two different networks, network layer need to do that process. But if it happens within the same network, no need of network layer. The network layer breaks up segments from the transport layer into smaller units. We can call it packets on the sender's device and reassembling these packets on the receiving device. So let's move to next layer. Next layer is data link layer. Data link layer is also similar to network layer. If data transfer between two different networks, network layer needs to do that process. But if it happens within the same network, no need of data link layer as previous layer. The data link layer takes packets from the network layer and breaks them into smaller pieces called frames. So our last layer is physical layer. In this physical layer, we transfer data into switch and cable like physical devices. And the data gets converted into bit stream in this physical layer. We can get examples as include Ethernet, RJ45, likewise. Our next model is TCP/IP model. TCP/IP model stands for Transmission Control Protocol, Internet Protocol. TCP/IP is different from ISO/OSI model. OSI has 7 layers as mentioned in above sections, and TCP/IP has only 4 layers. It's shown in figure. In other words, TCP/IP helps to determine how a specific computer should be connected to the internet and how data should be transmitted between them. Let's move on. Let's discuss about what are the layers of TCP/IP model. There are 4 layers as I mentioned above. First one is application layer. This is called process layer. It's the combination of application, presentation and session layers of OSI model. It's shown in figure above slide. It is responsible for node-to-node communication and controls user interface specifications. We can get examples as HTTP hypertext transfer protocol and FTP file transfer protocol and also HTTPS likewise. Let's move to next slide. Transport layer. Transport layer is called host-to-host layer. It is similar to transport layer of OSI model, and it is responsible for end-to-end communication and also error-free delivery of data. And the 2 main protocols present in these layers are Transmission Control Protocol TCP and User Diagram Protocol UDP. Next layer is Internet layer. Internet layer is, in earlier we discussed about standard bodies and layered architecture. Now let's move to data communication fundamentals. You know, nowadays data communication is the main things in the modern life. Let's see what are the terms of data communication. The term telecommunication means communication at a distance, and the word data refers to information presented in whatever form. And also it is agreed upon by the parties creating and using the data. That's the telecommunication and data terms meaning. The data communication are the exchange of data between two devices via some form of transmission medium, such as via cable or wireless media. Okay, let's go through our flow of wireless network technology. In this slide, we can get clear idea about differences between data and signals. In data communication, we must know about what is data and what is signals. First, we can describe data as data are raw facts that are used to transmit signals, and also signal is transformed way of data to electromagnetic waves. Remember, it's the electromagnetic wave. When transmitting video or photograph, first that video or photograph is in data form. To transmit it over the network, first it should be converted to electromagnetic signal. And data can transfer by using physical wire or radio waves. Without convert, it cannot be transmitted. I think that will be enough to get basic idea about differences between data and signals. Now, let's move to next slide. Both analog and digital signal can be periodic or non-periodic. A periodic signal completes a pattern within a measurable time frame. It called period and repeats that pattern over the subsequent identical period. The completion of the one full pattern is called a cycle, as in figure. A non-periodic signal changes without exhibiting a pattern or cycle that repeats over time. So let's discuss about what is a sine wave. In that figure, there's a sine wave. The sine wave is the most fundamental form of a periodic analog signal. A sine wave can be represented by three parameters. First one is peak amplitude, second one is frequency, and third one is phase. These three parameters fully describe the sine wave. Then what is the peak amplitude? Sine wave can be represented as simple curves within the time. When sine wave is increasing to highest amount of the wave, that point can give us as peak amplitude. And also peak amplitude can be measured in watts. Next topic is period and frequency. The period is the duration of time of one cycle in a repeating event. One cycle of sine wave refers to number of period of 1 second. If you want to transfer data from one point to another, either using by physical wire or by using radio waves, it can measure the periods as above equation. T equal 1 by f. Frequency is the number of cycle of a repeating event per unit of time. Frequency is formally expressed in hertz. For example, if 30 events occur within 15 seconds, the frequency is 2 hertz. Wavelength. Simple meaning of the wavelength is distance between corresponding points of two waves. And in this figure, we can get clear idea about wavelength. Next main topic is phase. Phase describes the position of the waveform relative to time zero. It measures how many degrees are shifted within the first cycle of wave. If it shifts in one half of a period, it can be measured as 180 degrees. And also if it shifts in 1/4 of a period, it can measure as 90 degrees. And so on as this figure. Next main topic is time domain and frequency domain. Time domain represents amplitude of sine wave against the time period. And also it shows how a signal changes over time. We can determine amplitude, phase, and also frequency using time domain graph. Then next is frequency. Frequency domain represents amplitude of sine wave against the frequency. And also it shows all the peak values of amplitude and frequency. This can be used to identify peak values and frequencies immediately. This is very useful when showing more than one sine waves. Okay, let's discuss about what is the bandwidth. It can express as the maximum amount of data that can be transmitted emitted in a fixed amount of time. Let's see, if there are frequencies as 1000, 2000, 3000 and 4000, bandwidth is 4000 minus 1000. Answer is 3000 Hertz. Digital signal representation. In addition to being represented by an analog signal, information can also be represented by digital signal. For example, 1 can be encoded as a positive voltage and 0 can be encoded as 0 voltage. A digital signal can have more than 2 levels. In this case, we can send more than 1 bit for each level. In next slide, we will discuss about 2 signals, and one with 2 level and the other with 4 level. In this figure, it shows a digital signal with 2 levels. It sends 1 bit per each level. 8 bits sent in 1 second. Bit rate is 8 bps. In this diagram, it shows a digital signal with 4 levels. It sent 2 bits per each level. 16 bits sent in 1 second. Bit rate is 16 bps. Let's discuss about features of analog signal and digital signal. Best example for analog signal is sound or human speech. It can transmit over an electrical copper wire, and also the signal flow through the type. Then next move to digital signal. Let's move to features of digital signal. Digital signal has 2 levels as 0 and 1s, and also digital signal can have only a limited number of values. Next one is transmission impairment. There are 3 types: noise, attenuation, distortion. First one is noise. Analog signal embedded with noise. Noise is unnecessary current in copper cable. Also, it may corrupt the signal. When transmitting signal, it creates extra signal which are not necessary to transmit original signal. If signal is amplified, noise are also amplified. Then next one is attenuation. Simple meaning is attenuation is when signal travel using transmit media, signal levels goes down. It called attenuation. Next one is distortion. Distortion can occur in a composite signal made of different frequencies. Analog to digital conversion. Pulse code modulation, PCM. There are many modulation techniques which are classified according to the type of modulation employed. All of them, the digital modulation technique used in pulse code modulation. A signal is pulse code modulated to convert its analog information into binary sequence, ones and zeros. The output of PCM will resemble a binary sequence. In this figure shows an example of PCM output with respect to values of given sine wave. Next, let's get a brief idea about modulation. Modulation is the process of varying one or more parameters of carrier signal in accordance with the values of the message signal. As the figure, the message signal is the signal which is being transmitted for communication, and the carrier signal is a high frequency signal which has no data, but it used for long distance transmission. There are 3 main signaling modulation process. Modulating signal, this is the useful signal, so which can be analog or digital. And next one is carrier signal, it's the high frequency signal. Then next one is modulated signal, it's the modified signal. Next we can move to analog modulation process and digital modulation process. In analog modulation process, there are 2 types, AM and FM. AM mean amplitude modulation and FM mean frequency modulation. Next one is amplitude modulation, AM. Amplitude modulation is change in carrier signal's amplitude according to modulating signal. as in this figure. Next one is frequency modulation, FM. Frequency modulation is frequency of carrier signal is changing according to the amplitude of original signal. This figure is shown frequency modulation. Now let's move to digital modulation process. There are three types, mainly three types: ASK, FSK, PSK. Amplitude shift keying, frequency shift keying, phase shift keying. Let's move to amplitude shift keying. In this digital modulation process, amplitude of carrier signal is varying when frequency and phase is constant. So ASK process with two signals. Subpart is binary ASK. It represents binary data. So it called binary amplitude shift keying. One level is 0 and another level is varying according to amplitude. In this modulation shows 0 values for low inputs and give the carrier output for high input. Next one is frequency shift keying, FSK. In this digital modulation process, frequency of carrier signal is varying when peak amplitude and phase is constant. In BFSK has two signals with different frequency. The binary ones and zeros are called mark and space frequencies. As figure, in binary frequency shift keying, modulated wave is in high frequency in high input and modulated wave is in low frequency in low input. Next one is phase shift keying, PSK. In digital modulation process, phase of carrier signal is varying when peak amplitude and frequency is constant. In BPSK, binary frequency shift key has only two levels of phase is 0 and another one is 180 degree. Carrier signal takes two phases of signals. One signal element represents one digit. Let's discuss about multiplexing. Multiplexing can use when signal has low bandwidth and transmitting media has high bandwidth. There are three basic types of multiplexing techniques. In here, I mentioned about two main types, FDM and TDM. FDM means frequency division multiplexing and another one is time division multiplexing. In FDM, give a small bandwidth to one channel. In other words, low bandwidth combine and go through high bandwidth. In TDM, it's a technique for combining several low rate channel into one high rate. In TDM, incoming signals are divided into equal fixed length time slots. In other words, give some time slot to transmit limited time of transmission. In above slide, we discuss about main things of data communication fundamentals. I hope you all get some knowledge by using my presentation and see you soon. Thank you for everyone.